A very good evening to all of you. This is Shivam Shukla and here I am to solve a problem on resultant of parallel force system. There are three sub-questions in the main problem. What are those? Let us go through it. Location of the resultant force with respect to a point. Second, replacing the single force, that is the resultant force, by a force coupled system at a particular point. Replacing the resultant force by two parallel components at two different points A and B. Let us see how the question statement goes as. Figure shows a parallel system of four forces and two couples. Now there are four sub-questions in it. Replace it by a single force and obtain its location from point A. Now my dear friends, single force is nothing but the resultant force. Replace it by a force coupled system at point A. Replace it by a force coupled system at point D. And then replace it by two parallel forces at B and D. So let us go through it, my dear friends. Okay, this is the questions diagram. It is having four parallel forces and two couples. Even if we don't draw the FBD, it's okay. Let us proceed with the diagram. First part, resultant of this parallel force system is given as, since all the forces are acting along the vertical direction, the resultant is given as R is equal to summation Fy acting towards upward sense as positive, minus 8, minus 4, minus 10 plus 12. So R is equal to minus 10, that is 10 kilonewton downwards. Now, obtain its location with respect to a point A. So location of the resultant with respect to a particular point, that is point A, as you can see in the questions diagram. Extreme leftward point, this is point A, and the other points are given. Where 4 kilonewton is acting is point B. Here it is D and C. Okay, let us proceed with it. Now R we already got it. Now by Warrington's theorem, algebraic sum of moment of all the forces about A is equal to moment of resultant about A. While locating the resultant, we have assumed let the resultant R be located at a perpendicular distance D to the right hand side of A. So as you can see the diagram now, as you can assume and sitting at anchoring at point A here at the left extreme, already the force which was acting 8 kilonewton at point A, it will not be considered because there is no perpendicular distance with respect to point A. That is why 8 into 0 will be 0. That is why this force won't come. Now algebraic sum of moment of all the forces about A will be 4 plus 4. Why plus? Because 4 is causing the body to rotate in clockwise sense with respect to point A, and we have considered the rotation direction of rotation in clockwise sense as positive. So plus 4 into 3, then plus 10 into 6, minus this minus 12 into nothing but 9. This total distance as well as minus 30 plus 80. Because these are the couples. Couples already they have been multiplied, so their distances are not expected to be multiplied, my dear friends. You can check it. 4 into 3 plus 10 into 6 minus 12 into 9 minus 30 plus 80 is equal to 10 into D. So therefore R is equal to 10 kilonewton at a perpendicular distance. D is equal to 1.4 meter to the right of 1.4 meter to the right of point A. So now, as you can proceed further, point B. What was the question? That is sub question B. I will be just going through it. Replace it by a force coupled system at point A. Let us go to the part B directly over here. So now, first of all, equivalent force is nothing but the resultant force. Straight away I am picking up this resultant force which was at 1.4 meter and I am placing it at point A. By the concept of replacing the force by a force coupled system, how do we do it? Now, what do we do it and how do we do it? Over here, it will be the distance that you can see, it is 1.4 meter. Here it is 1.4 meter, the distance between point A and R. Straight away, summation of moment of forces about A, if I take, it will be about A I am sitting, that is why it will be 10 into 1.4. It is nothing but 14 kilonewton meter in clockwise sense. So my dear friends, it will be force couple system will be resultant R acting at point A and MA is equal to 14 kilonewton meter, which will be acting again at the same point. Now the same question which is asked for point D, equivalent force is resultant force, that is we are supposed to replace a force by a force coupled system at point D. Now here simply we have done a bit different trick. The answer remains the same. Now my dear friends, from point A, actually the resultant force was at a distance of 1.4. If I see from point D, the resultant force is at a distance of 4.6. If I directly multiply this this particular force force with the distance, so I will be getting the value as 14 kilonewton meter. So how do we do it? Summation of moment of forces about D acting in clockwise sense as positive. For getting this, let us go to the main questions diagram, which will be helpful for us to locate the moment of forces about D. So here it is, my dear friends. Okay, once I see this diagram, if I am sitting at point D, let me say D is over here, so it will be about point D minus 8. I am sitting over here at point D. Try to understand, my dear friends. Summation of moment of forces about D minus 8 into 6. I am anchoring over here. Why minus? Because 8 is causing the body to rotate in anti-clockwise sense. Again minus 4 into 3. Again this 12 kilonewton is causing the body to rotate in anti-clockwise sense. So minus 12 into 3. Again these couples are there, so it will be causing anti-clockwise rotation. That is why minus 30 plus 80. Let me just go to that equation so that you all will understand it in a better fashion. Let us see, my dear friends, as we said, minus 8 into 6, minus 4 into 3, minus 12 into 3, minus 30 plus 80. The sum of total comes out to 14 kilonewton meter in clockwise sense. So this was the force coupled system at point D. Last but not the least, replace the resultant force by two parallel components at points B and D. So we have assumed, let the two parallel forces at points B and D be FB and FD. We have assumed both of them to be acting in downward sense. Our resultant was actually acting over here at a distance of 1.4 meter from point A. So now from point B it is at 1.6 meter, and from point D it is at a distance of 4.6 meter. So now, my dear friends, actually since there are two unknowns, it's a parallel force system, we should be having two equations with us. Now first and foremost is R is equal to summation Fy acting in upward sense as positive. That is nothing but minus 10 is equal to minus Fb minus Fd. That is Fb plus Fd is equal to 10. That will be equation number 1. Now by Varignon's theorem, summation of moment of forces about B is equal to moment of resultant about the same point B acting in clockwise sense as positive. So if I go to this diagram again, so how it will be? So it will be, I am considering about point B. So only one force is there, that is Fd into 3, and it will be equated to minus 10 into 1.6 because I am assuming it about point B. So here it is Fd is equal to minus 5.33. Now friends, here you may get confused. Since our initial assumption was that Fd and Fb both are acting vertically downwards, but even though we have framed the equations, and now when we got the value of Fd as negative, that means our assumed direction of Fd went wrong. That is why Fd is equal to 5.33 kilonewton acting in upward sense. I hope it is clear. I repeat it again, my dear friends. Since the value of Fd that we have assumed in the problem was Fd acting vertically downwards, as you can see in the diagram over here. But now already the signature we have considered as negative, but still since we have got the value here as negative, that means our assumption of the direction went wrong. That is why Fd is equal to 5.33 kilonewton acting in vertically upward sense. Now Again, we are just putting or substituting this value in equation number 1. So FB plus in bracket it will be minus. Why minus? Because actually we got the value as minus and there we have already assumed it in downward sense. That is why here it will be minus. 5.33 is equal to 10. So FB is equal to 15.33 kilonewton, my dear friends. Again the value has come positive. That means it will be in vertically downward sense only. So here we have solved 4 sub questions in this particular problem. If we consider in the university paper, you may get maximum 2 sub questions in it, which will be asked for 4 marks. If there are 3 sub questions, it will be asked for 6 marks. So please do like, subscribe and share this video. Thank you for watching this video.